Hello everyone, welcome to edupediaworld.com and thanks for watching Edupedia World videos. This is Vikas Patil. This is the 5th chapter of grade 9, Materials of the Earth's Crust. In this chapter, we are going to explore in detail about the materials that make up the outermost layer of the earth, the crust. If we look around us, we will find ourselves surrounded by materialistic miracles which are the outcome of indigenous work by humans in the field of science and technology. Humans have used their ability to make use of all the gifts of nature and convert them into products which have tremendous utility. The tall buildings, machines, luxury items, vehicles, and almost everything that we use in our day-to-day life is an outcome of the human ability to convert gifts of nature to useful products. We all appreciate the beauty of monuments like the Taj Mahal, Red Fort, etc. We love to move in luxurious cars, fly in planes, and wear expensive clothes. If we look closely, all these things made by humans have been derived from the land we live on, except the organic material which have come from living beings. This outermost thin layer of the earth is known as the crust or the lithosphere. The crust provides us with materials which are used as raw material to produce various products that we use in our daily life. In this chapter, we are going to explore about these materials of our crust. This chapter has been divided into 6 topics: rocks and minerals, igneous rocks, sedimentary rocks, metamorphic rocks, the rock cycle, and ores and gemstones. This is the first session of the chapter. In this session, we are going to learn in detail about rocks and minerals. In this session, we are going to try and achieve the following objectives: develop understanding about the properties of rocks, develop understanding about the properties of minerals, compare and contrast between the rocks and minerals, acquire knowledge about the common minerals that form rocks, develop awareness about the Mohs scale of hardness. Before we begin our exploration about the rocks and minerals, let us look at some of the common misconceptions that exist regarding the same. First, not all the minerals have chemical properties. This is wrong. All minerals have chemical properties. Second, texture and luster mean the same. Again, this is a misconception. Texture and luster are different. Rocks are made up of similar minerals. Again, this is not correct. Rocks are composed of a combination of different minerals. Last, we can get only metals from the rocks. Again, this is wrong. All the minerals, metals, non-metals, are obtained from the rocks. Let's begin and explore some more facts about rocks and minerals. At one time or another, you have probably held a rock in your hand. Try to recall the texture. Was it smooth, polished by the force of sand and salt water pounding it onto the beach? Was it rough and cracked, left exposed for centuries to the wind and sun of a canyon wall? Recall the color. Was it coral and pink, like the colors of Bermuda's sand? Was it fiery red, like the colors of Arizona's canyons? Recall the size. Was it a handful heavy with the weight of being worn? Was it a tiny pebble, a small fragment broken off from what it once was? Rocks are our world. The planet Earth is essentially just one big interesting rock, sometimes called the third rock from the sun. The multifaceted rock we live on support life in many ways. The deep oceans, the vast deserts, and the high mountains are just a few of the ways rock emerges and supports life. Rocks are the source of all the minerals. Let us understand what rocks and minerals are. Minerals. A mineral is defined as a naturally occurring inorganic substance having a fixed chemical formula and distinct physical properties. The above definition essentially mean that materials like steel, glass are not minerals since they are not naturally occurring, and wood is not a mineral because it is not inorganic. This also means that every mineral has a chemical formula, no matter how complex it is. Some, like diamond, have a simple chemical formula, but the chemical formula of another gemstone, emerald, is very complex. It is also possible that two naturally occurring inorganic substances may have the same chemical formula but are known by different names as minerals since their physical properties are different. The best example in this regard is diamond and graphite. Both are pure carbon, but while diamond is the hardest mineral known, graphite is almost the opposite. The most common rock-forming minerals include quartz, feldspar, mica, calcite, and clay. Amongst the physical properties of minerals, color, hardness, and luster are easily noticeable and therefore serve as the primary traits used in order to identify a mineral. Other physical properties such as streak, crystalline structure, cleavage, and optical properties are less noticeable and are resorted to mostly when ready identification using color, hardness, and luster becomes difficult. Minerals may be of several colors. In fact, the colors of non-living objects that we see around us are because of the minerals that the objects are composed of. The most common mineral, quartz, for example, occurs in several different colors, ranging from colorless to white, red, pink, grey, yellow, purple, and even black. In order to describe the hardness of a mineral, mineralogists use the Mohs scale of hardness. On this scale, talc is the softest mineral with a hardness of 1, whereas diamond is the hardest mineral with a hardness of 10. Rather than having a specific basis, the scale is based on observation and description. Luster. The luster of minerals can range from being dull and earthy, as in bauxite, to being glassy or vitreous, as in quartz, or metallic, as in hematite. Rocks. A rock is defined as a mixture of minerals in the solid state. So as per the definition, a rock is mixture of minerals. This means that all rocks contain one or more minerals in varying proportions. A rock may contain only one mineral and therefore may be described as being monomineralic. For example, the rock dunite, one of the chief rocks believed to be present in the mantle, consists of only one mineral, the olive green colored olivine. However, most rocks consist of more than one mineral. For example, granite consists of quartz, feldspar, and mica, whereas marble consists of calcite and quartz. Sometimes two rocks may be composed of the same mineral and yet may have different names. Also, for something to be called a rock, it essentially has to be in the solid state. Molten rock material is known as magma if it is buried under the earth's surface, and lava if it occurs upon the earth's surface. This goes with our observation of rocks. We see them in solid state only, and therefore the use of the term rock solid. Geologists have identified over 300 different rocks, each different from another in one or more ways. Nonetheless, the classification of rocks based on the mode of formation into igneous, sedimentary, and metamorphic is a good starting step towards understanding rocks. Igneous rocks are formed due to the cooling and solidification of molten rock matter, either on the surface of the earth, underwater, or deep beneath the earth's crust. Sedimentary rocks are formed when pieces of existing rocks are deposited in layers and further made compact due to the pressure of overlying layers. Metamorphic rocks result when existing rocks are subject to the action of intense heat and pressure, resulting in alteration of existing structure and formation of new minerals. Rocks may be identified in the field constituent minerals and texture. The term texture is used to describe aspect such as size and shape of mineral crystals, as well as orientation and relationship of mineral crystals with each other. When identification with naked eye is not possible, then the rocks are taken for microscopic examination. Following are some examples of how the texture of a rock is an important testimonial of its origin. The texture of a rock can be glassy, like in obsidian, or coarse grained, like in granite or gabbro, or rough with well-rounded grains, like in sandstone, layered structure like in shale, granulitic structure like in marble. This was all for this session. In the next session, we will focus on igneous rocks. Don't forget to watch. Thank you.